Today we're going to talk about finding the area of parallelograms. This is in Chapter 4, Section 1. So our learning target is I can find the area of parallelograms. Okay, so a parallelogram looks something like this. Okay, in case we forgot what that looks like. It has four sides. It's a quadrilateral that has two pairs of parallel sides. For example, this side is parallel to this side, meaning those lines will keep going straight and they'll never intersect. They're kind of right across from each other. Okay, now you can't tell from my picture because I just kind of drew it fast. But then this side will be parallel with this side, meaning that if they keep going on forever, they'll never intersect. They're kind of right on top and bottom of each other. Okay, opposite sides have the same length, so meaning that this length right here is the same as the length on the top. The length on the left is the same as the length on the right. Okay, but these two can be like different lengths. It's just that the top and bottom are the same and the opposite sides, kind of like a rectangle. All right, we're going to be finding the area of a parallelogram, which is the amount of space inside an object. Okay, now we should have already talked about this in class. I'm just going to kind of recap the activity that we did in case you were absent or we moved a little too fast for you and you want it re-explained to you. Okay, so in class I passed you all out a parallelogram that looks something like this. And we cut it up and tried to decide how we could find the area of it using shapes that we already knew. Okay, so what we did in class is we took that parallelogram and we wanted to cut this little triangle off, flip it upside down, or I guess we don't even have to flip it upside down. We just have to move it right there. Okay, because now we have in purple, or maybe I'll use a different color, blue, we have a rectangle that we would know how to find the area of. Okay, we would just count for that base, count for that height or the length and the width. We're going to start using the words base and height to find the area instead of length and width, just because it makes more meaning of the word base and height as opposed to us not knowing which one the length and the width is. Base and height is a lot easier to find. So our base is the bottom and our height is how far it goes up. All right, so then we counted the dimensions of that rectangle using this parallelogram over here. We had counted 1, 2, 3, 4, 5, 6, 7, all the way to 12. So we found that that rectangle had 12 boxes on the bottom. And then we would have counted how many boxes for the height. We'd have counted 1, 2, 3, 4, 5, 6, 7, 8 for that height. And we could then find the area of this shape by doing 12 times 8, because for a rectangle, it's base times height, or 12 times 8. Okay, length times width. So using what we can do in our activity, we can find the area of this parallelogram by doing the exact same thing. We cut off that triangle, move it over here. We now know that our base of our parallelogram is 12 and our height is 8. Okay, so we would just do 12 times 8 because we're not changing the amount of boxes. We still have the same exact amount of boxes over here when we cut it off and put it on over here. The amount of boxes inside is the exact same amount as it was before. You didn't add any boxes to that piece of paper that I gave you or take any away, or you shouldn't have. So that what that means is that the formula, or the way that we're going to find the area of a parallelogram, is by multiplying the base by the height. Okay, we shorten that up by saying area A equals base B times our height H. So this is kind of the formula that we're going to use, and we're going to want to write that down for every single problem that we solve for our work. Okay, the base is one of the sides of the parallelogram. Okay, so if we have a parallelogram over here, the base is going to be one of these sides. Okay, one of the sides. Now the height, I'm going to kind of start over because that got a little sloppy, is going to be the distance connecting two of the bases. Okay, so the distance from this base to this base. So it does have to be a straight up and down line. Okay, so for example, if this was 8, like it was in our example over here, this is 12. This would be our base, and this would be our height. This is one of the side lengths, and this line right here is connecting it to the one across from it. Okay, if we were given a distance right here of 9, that slant height is not the height of the parallelogram. The height has to be a straight up and down line connecting the two sides, straight up and down. So since this is not straight up and down, that is not the height of our parallelogram. Okay, now it can get a little tricky because sometimes they kind of have the parallelogram like flipped. Okay, so they give this distance right here is 12. Okay, and then they say this is 9 or whatnot. Okay. Now for this, the height is connecting these two sides. So our base has to be either this side or this side. And we know that they're the same distance. So for this problem, we do 9 times 12 for that base times the height. The height always connects the two sides, the base that we're going to use. Okay, straight up and down line. Doesn't matter if it's flipped or not. Okay, so that was kind of a review of what we talked about in class. Now we're going to get into some examples that we haven't talked. So follow along on your paper if you haven't already then. We're going to determine what the base and height is of each parallelogram, okay? Because you're going to notice in both these pictures there's 3 different numbers, but we only need to use 2 of them to find the area. We only need the base and the height. Okay, I think finding the height first is the easiest because it's that inside distance, and sometimes it can be outside. For example, sometimes they can, that was not straight. Sorry, I'm trying. They can write the height on the outside as a dotted line, but the height should always be written as a dotted line, okay, because that helps you, because it's not a part of the shape, it's just kind of imaginary line there to tell you what that distance is. All right, so the height of this parallelogram, which is connecting 2 bases, is going to be 8. So our height is 8 centimeters. Now, our base is the one that connects to that height. So since this side and this side connects to that height, it's telling the distance between those 2 bases, we will use 16 centimeters as our base, not 10, because our height does not go this way. Okay, pause the video, try number 2 on your own, find out what the base and height is, and then resume the video to check. All right, so first thing we're going to do is find our height. That's the distance between 2 bases. So here we have that distance written as 14 inches. Okay, now that 14 connects this base and this base, so we're going to use the distance 20 inches to find that area. Okay, now that we know how to determine which number is our base, which number is our height, we're going to work on finding the actual area of the parallelogram. Okay, we do have to show our work. We have to show our work in these 3 steps. On a quiz, on a test, if you don't show these 3 steps, you will only be getting, let's say you just write what the answer is, you'll only get 1 point out of the 3 possible points. Okay, and if you do that on your whole test, you're only going to get 1/3 of the problems or 1/3 of the points that you could get, and that's going to give you a 33% on your test, which is an F. Okay, so we want to make sure that we're showing our work. We'll do this on our homework tonight as well. So the very first thing we do is write our formula. We can write the shortened version of A equals B times H, meaning area equals base times height. We then use substitution, so then we're going to put the numbers in for the base and put the numbers in for the height. Since we don't know what the area is, we just leave that in A. So we would have A equals 16 times 8 for that second step. Okay, then third, we write our answer with the correct label. Remember, for area, it's units squared because it's inches times inches, or centimeters times centimeters, okay, which would be centimeters squared or inches squared. All right, so let's try number 3. Very first thing we're going to do is write our formula. Area equals base times height. We're going to leave our A as area because we don't know what the area is equal to yet. We're going to determine what numbers are base, what numbers are height. Well, our height is 22. That's the line that's connecting those 2 bases. Our base is the one that height connects. That's going to be one of those 2 sides, which is 16. Okay, off to the side, we're going to do 22 times 16. 6 times 2 is 12. Write our 2, carry our 1. 6 times 2 is 12, plus 1 is 13. We have no more digits, so we just write our 13 here. Now we are moving on to the 1 into the tens place, so we have to add a 0 placeholder, erase our remainders. Cross off our 6 because we're done with our 6. 1 times 2 is 2. 1 times 2 is 2. Add them up. 2 plus 0 is 2. 3 plus 2 is 5. 2 times 1 is 3. No decimals, so our answer is 352 inches squared. We have to have that label. If you're feeling like you got the hang of this, I want you to pause the video, try number 4 on your own, and then resume the video to check and to do the last example together. So for number 4, we have to show our work. So the very first thing we're going to do is write our area equals base times height. Remember, you should only be watching this if you already tried to do it on your own. Area equals our height, that's connecting the two bases, is going to be 8. Our base, which is one of the sides that the height is connecting, is 12. To the side, we would do 12 times 8. 8 times 2 is 16. 8 times 1 is 8 plus 1 is 9. We should get area equals 96, but I'm not finished. I need to put a label. Feet times feet is feet squared. Okay. All right, number 5. Here we have a shape, and we only want to find the area of the shaded shape. So we only want to find the part that's yellow. Okay, so the way we're going to do this is we're going to find the area of 2 different shapes. We're going to find the area of this big parallelogram, and then we're going to find the area of this little rectangle, and we're going to subtract the area of this little rectangle, because then what we're going to be left with is all the space that's around it. Okay, so the very first thing I want you to do is number the shapes, okay, so that I know what your work is for which shape. So the very first thing I'm going to do is find the area of the big shape, okay, that part that's shaded. That's going to be my shape 1. And I'm going to write my formula. I have to show those 3 steps. Area equals base times height. Area equals my height is 5. That's the height that's connecting those 2 distances. My base, which is connected to that height, is a 7. So I'm going to have area equals 7 times 5. Feet times feet, feet squared. Okay, I'm going to kind of draw a little line because I wrote a little big for that example. So I found the area of my big shape, my big shaded yellow shape. Okay, and then I'm going to find the area of the smaller shape. I'm going to label that number 2, and I'm going to kind of erase my lines so you can see my 2. Okay, and that's just a rectangle. So to find the area of a rectangle, I still do area equals base times height, and I should still be writing out that formula. Okay. So I have area equals, my base is 1, my height is 3. 1 times 3. My area equals 3 feet times feet, feet squared. Okay, last but not least, I have to subtract that small shape from the big shape because I want to be left with what's shaded in. Okay, so I have to subtract 3 from 35. So I have to take 35 minus 3. I should not be taking 3 minus 35 because that would be a negative number, because something small minus something bigger than it, it's going to be negative. And a shape can never be negative because it takes up some amount of space. Okay, so we have to do 35 minus 3. And that shaded shape is going to be equal to 32 feet squared. And that's that. If you still have room left in the summary box, just write a quick little sentence or 2 saying how you find the area of a parallelogram. Talk about that base, talk about that height, talk about how to find that height and how to find that base, and then you can get started on your classwork.